Well, hello, fifth grade. We're going to do a little bit of rounding today, rounding of mixed numbers. L92, make sure you're marking up in your notes and doing everything you should. So before we get into rounding mixed numbers, which is not something we've done much before, we do want to kind of review our ideas behind decimal rounding, which is something that we teach kids earlier on. So let's take certain numbers. Let's say I had 2 and 3/10. Let's say I had 8 and 7/10, and I had 9 and 5/10. Now, if you remember from rounding decimals, and here, let's say they want us to round each of these to the nearest whole or the nearest ones place value, right? So we know that the nearest whole, what we want to do is, there's kind of a way that we've shown this, that we would kind of underline the whole, that's the 2, and we box that off, and then we point to that value, that digit, which is our decision-making digit, right? And we know that if that decision-making digit is less than 5, we ultimately round down. And in that case, it would be 2. For our second example, again, we'd box off, we'd point to our decision-making digit. That decision-making digit is 5 or greater. Therefore, we're going to round up and call that 9. Yeah, this is all review. When we look at this last one, and we point to our decision-making digit, again, the rule for decimal rounding is if it's 5 or greater, we're going to round up. So this 9 and 5/10 becomes 10. Now, what we have to do is take that idea and move that into mixed numbers. So I'm going to put the same exact value down, just in mixed number form. So the first one was 2 and 3/10. That would be written this way, right? The second value we looked at was 8 and 7/10. Oh, sorry. So obviously 2 and 3/10, whether it's in mixed number form or decimal form, is going to round to the same number. We know that this is rounding down, and as we saw before, it's going to round down to 2, right? So the 8 and 7/10 would look like this, just in mixed number form. And we know before it rounded to 9, nothing about what we're doing is going to change that. So this one still rounds up to 9. I said round down. I meant round up. And then the last one, we know we would write it this way, 9 and 5/10 as a mixed number. And before it rounded up to 10, so that's still going to happen. But the kicker is right here, though, that 5/10. Hopefully you realize 5/10 could be something else. But we'll get into that in just a moment, because this all comes down to a statement we want to make. What we want to focus on when rounding mixed numbers is the fractional portion. And we want to think about, is the fractional portion, is it less than, greater than, or equal to? Can anyone guess? Go ahead. 1/2? Yes. Wow, that's a very deep voice for a fifth grader. That was pretty amazing. But you are right. That's what we're focused on. We're looking at the fractional portion of the mixed number, and we're going, hey, is that fractional portion less than 1/2? Is it greater than 1/2? Or is it equal to? Because that's going to decide whether we'll round up or round down. So let's take this. Let's say we have 5 and 2/3. And what I want to do is we're going to round to the nearest whole, right? Let's write that in. We're going to round to the nearest whole number. I want to focus on that fraction. Go, is 2/3, is it less than, is it greater than, or is it equal to 1/2? So, I mean, we could draw a picture for this. So if I drew 2 circles, and I broke one of them into 2 parts, and I broke the other up into 3 parts, and on the right side I shaded that would represent 1/2, right? Okay. And then for my one that's broken up into thirds, I'd go boom, boom. Well, which one's greater? Like, think of cake. If you love cake, which one would you want? The one on the left or the right? I think we'd all have to conclude, if we love cake, that we take the one on the left, which represents our 2/3. Therefore, we can say that 2/3 is greater than, right? It's greater than. And if it's greater than 1/2, what do you think we're going to do? Yeah, we're going to round up. And we're going to round up to the nearest whole, which would be 6. Boom. Let's look at another example. What if I had 8 and 1/4? Again, I want to focus on this fractional portion. That's the important part, the fractional portion. And I think how does it relate to 1/2? Is it less than, greater than, or equal to? Now, we could draw pictures. Another thing we could do is we could take that 1/2 and make it have a shared denominator. So if I took 1/2 and I go, hey, I want to compare it to this 1/4, so I'm going to give it a denominator of 4 and do that little kindergarten boxing. So 2 times what equals 4, and whatever that what is, it's 2. I have to do the same here. So 2/4. Now, is 2/4 greater than 1/4? Well, yeah, think of cake. So therefore, we see that this 8 and 1/4, the 1/4 is less than. And if it's less than, guess what we're going to do? You got it. We're going to round down. Round down to the nearest whole number, which would be 8. Boom. All right, what about this guy? What if I had 9 and 4/8? So again, our focus is always, is it less, is that 4/8? Is it less than? Is it greater than? Or is it equal to? Well, we could draw pictures. Another thing we do, we take that 4/8. It looks like it can be reduced. What would I reduce it to? Well, its GCF is 4. So if I divided that by 4 and divided that by 4, what would I get? 1/2. Oh, so it's equal to. Well, what do I do if it's equal to? Well, okay, so if it's equal to, that means I could write 9 and 4/8 as 9 and 1/2. Now, if I turn that into a decimal form just for a moment, wouldn't it be 9 and 5/10, or visually 9.5? And remember what we do there. We box off, we point, decision-making number is 5 or greater. So what are we going to do? Well, yeah, we would round up. So if your fractional portion is equal to 1/2, you're likely going to round up if it asks you to round to the nearest whole number. And that would be 10. Boom. Now, when does this come up? Well, it comes up in a couple ways. One, they could just literally ask you to round. And I want to practice that a little bit with you, because it all comes down to an earlier lesson of when recognizing halves. So if we take something like 1/2, we know we can name several fractions that are equal to it. One we already talked about. How about 4/8? We could go with 5/10. We could even go out on a limb and say 16/32. Now, remember how that works. All 1/2s have this kind of nature. So if you think about from numerator to denominator, I would take my numerator, multiply it by 2, and if it's a half, then that should equal my denominator. Yeah, 4 times 2 is equal to 8. We can also go the other way. So 10 divided by 2 should be my numerator. Yep, 10 divided by 2 is 5. So that's why these are all halves. What about something that's less than half? And we play that game. Now remember, when it's less than half, we're going to round down. So if I took something like 1/3, or maybe I took 2/5, or maybe I took 7/15. So if I did that same little thing, if I take my numerator and multiply down 1 times 2, guess what? That's less than 3. Therefore, this fraction must be less than 1/2. Or if I go the other way, I say, so if I times 2 there, what if I do this and I divide by 2? Well, 5 divided by 2 is 2.5. Therefore, this fraction must be less than. Same with our 7/15. So if a fraction's less than a half, we're going to round down. How about if it's greater than a half? Well, yeah, we're going to round up. And so, again, what are the nature of those kind of fractions? 2/3, 4/7, 19/37. If I take that 2 and I multiply it by 2, I will exceed my denominator, right? If I take my denominator and I divide by 2, I will be less than my numerator, right? And in those cases, if I have something that's greater than a half, I want to round up. What about if it's a half? If it's equal to a half? Well, if they're just asking you to round to the nearest whole number, you're probably going to just round up, and that's what you want. However, we might not always, and we'll talk about that in a moment. We got a few problems to do. Let's go now. Here's a pretty straightforward one. They just want you to round this to the nearest whole. It's 6 2/5. As we know, we're supposed to focus in on that fraction and ask ourselves, is that less than, is it equal to, or is it greater than? Well, again, 2/5, if I multiplied that 2 by 2, I'd get 4, which is less. So therefore, 2/5 is less than 1/2. Because it's less than, we're going to round down simply to 6. That's a pretty straightforward question, right? All focused on that fraction. Well, then we'll start to mix this in with other things. So go ahead and draw this up. I got a right triangle with the base at 8 7/8 inches and the height at 5 1/4 inches. Now, let's say we're going to consider area, and let's say a friend of yours came out and just like kind of looked at it and said, that thing's about 20 inches squared in area. Now, is that a reasonable estimate? Well, let's try it out. So again, we do have a formula for area of a triangle. So that's A equals BH over 2. We're going to look at our base. That's currently at 8 7/8, but we know we'd round up to 9, right? So let's plug that in. So our base is 9 inches. When we think about our height, we're at 5 1/4. Well, that would round down because 1/4 is less than 1/2. So we'll go with 5. Don't forget, we have to divide this by 2. So we do know that 9 inches times 5 inches is 45 inches squared over 2. And then, again, this is not all exact. So I did put equal signs, but really it should be we're approximating here. And so I could say that the area is approximately, and 45 divided by 2 is 22.5. Area is approximately 22 inches squared. So was your friend reasonable? Yeah, I'd say that's pretty reasonable. He's pretty close on. He said 20 inches squared, 22.5. We'll give that a yes. Besides area, another place this could come up is perimeter. So imagine they either told you about this rectangle or they drew it out and they said, hey, estimate the perimeter of this. So again, we do have a formula for perimeter. So we're going to say P equals 2L plus 2W. And then we're going to think about, that's our length, right? 15 1/8, but we would round that down. So from here on out, we'll use that approximate symbol because that's what we're doing. We're just estimating. Instead of calling it 15 1/8 inches, we'll just go with simple, we'd round down to 15, right? 15 inches. So we multiply that. Then we think about our width. It's at 10 3/4, 10 3/4. 3/4 is clearly greater than 1/2. I mean, think of cake. So I'd round up to the nearest whole would be 11. And then I do my math. P is approximately equal to 2 times 15 inches is 30 inches. 2 times 11 inches is 22 inches. Then I bring those together. P is approximately 52 inches. Approximately, right? That's about it. That's all we got. Hey, I know that for you, this is let me check. It is out into the future Tuesday. The day we choose. So we are testing tomorrow. You are still responsible for doing homework 92. I hope all is well with you. You can reach out to me anytime you want. L92, rounding mixed numbers. Bye.